Okay, so where we left off last time, I was kind of going through some of the wiring harness in the truck. I'd mentioned that I'd pulled the computer out, so this is it. This particular computer is kind of a couple different case designs, I believe, depending on the year. But for the most part, for the Cummins trucks like mine, it has these three plugs. Ends up laying out as C1, C2, and C3 plugs. I'm not really sure on model numbers. I haven't really looked into that a whole lot on the computer itself, but you'll notice that, you know, the fasteners that go along here on the sides, on the top, but then you get to this back corner and it's just like a book. You see where the aluminum was kind of folded down into a die around this whole board, and it's bent. So even though there's fasteners on that side and then there's fasteners here on this back side, once you take the fasteners out, I'm guessing you're going to have to bend this thing open. I was able to find a little more information about that on some other YouTube videos that were super helpful. If I can figure out how to do it, I'll put a link to one of the other YouTube channels where a guy was looking at computers similar to these. I don't believe they were Cummins specifically, but other Dodge Chrysler TCMs or computers that were doing similar things. So kind of again, just to reiterate where we were last time, I had noticed that this computer was heating up, and the spot that it was getting hot, it was right around in here underneath this plug down in this corner. And I've already tested this out a little bit, but I'll just walk through it real quick with you guys. So it was right here on my finger, and it was definitely on this side of the case. I could feel the back side of the case, and wasn't getting any heat from the back. So whatever it is seems to be on this side of the board. While this thing was in the truck, and again, this whole thing started kind of with as something, all of my symptoms were seemingly related to an ESS sensor being bad. And so I had replaced the sensor and then started heading down this direction, right? So I initially tested the harness at the ESS sensor, looking for voltages that made sense, coming out while the key was in the on position, looking for a 5-volt to ground signal out of at least two of the wires, and then after reading further, I now understand, I guess, that one is ground, one is a 5-volt reference, and the other is a 5-volt signal. So it should register as 5-volt also. And now I believe I've seen also that there's also 8-volt versions of these computers where the sensor voltages are a little higher. I don't really think that matters a whole lot, because in effect what I saw in the truck was that the voltages coming out were less than 1 volt. It was like 0.7 something of a volt, which no matter how you slice it, it isn't going to cut it. So even after unplugging everything else out of the computer, you know, these other two plugs, removed those, had only this plug, and would power it up and would get that voltage out. The concerning thing was that after I removed the computer, I brought it down here, I put it on my bench, and this would kind of be the logical next step, at least in my mind, for how to diagnose this. I wanted to verify that 100% that there wasn't something going on, let's say a short in the wiring harness, maybe a short in the connector itself that plugs down in there, that was shorting out my 5-volt reference to ground, causing it to pull that voltage down to 0.7 some volts, which could happen, and it could also cause the heating or something in this particular spot if it's the 5-volt voltage regulator chip down here that's drawing an amp or whatever. It could be the resistor or that voltage regulator package that's actually heating up and causing this problem. So I guess what I'm showing here now is just at least my process of testing this thing out on a bench. It's fairly easy to do. I just got a voltmeter over here set to 20 volts. I'm using a computer power supply right here. That's just a breakout board, but behind there is a computer power supply that thing switches on and off. I'm pulling my 12 volt and ground signal out of that. And then so right here behind it, I got, you know, a PCM connector pinout that tells me for these connectors, and this kind of describes things from the connector's point of view. You know, and then obviously this is kind of would be a mirror image of what that connector layout would be. But if you look really close, you can see down on those inside of those connectors that they are numbered. All these pins are numbered, so you can kind of at least you know, get your bearings and make sure that the number that you're plugged to down here corresponds to the number that I have on my sheet. So initially, or at least right now, I got it hooked up. You know, I have my multimeter hooked up here to a couple of pins. The couple of pins that I care about are number 4 is the sensor ground, and then I believe over here, I don't know if we can see this out of the shadow, number 17 is the 5-volt supply. So those are what I'm trying to measure off of. In order to power the board up, I got pin number 22, which is the fused battery positive, and then I also have over here, number 31, which is just the ground, right? And then so that being separate from the sensor ground. The sensor ground is my 5-volt ground that I'm going to measure from. This is going to be the ground that I'm going to put power to, or put my power supply ground to. So so let's go ahead and I'll switch it on, and we'll see what she says. So as it's powering up, oh, look at that, I'm even getting a different voltage reading than I was getting while this thing was plugged up in the truck. And then I'm just putting my hand right here on this case, just kind of feeling around, seeing if I notice any heat buildup down here, and I can feel that getting warm, kind of right under that label, and it's pretty localized. So anyway, so number 1, I know that this is a problem. I think, and I don't know this for positive, but I do believe that on a fully functional running computer, this thing shouldn't even be putting out voltage necessarily here, unless we're putting power to this pin number 2. So this is the fuse ignition. So when you kick your ignition switch on, at least in my mind, that's when this thing should come alive. So I'm also going to go ahead and, you know what I'm going to do? I'm going to reconfigure these wires, and let's take a look at what kind of amperage this thing is pulling just when it's just the battery and ground hooked up. And in my mind, in this state, it should be pulling next to nothing. But right now, it's obviously pulling enough to heat up the components. So let's reconfigure the wires, and we'll take a look at how many amps this thing's pulling just in what should be an idle state. Okay, so we got it rewired here. I just moved some of my jumpers around, got it wired in series now, in effect, where the battery voltage comes in here on what is that, number 22, where the battery voltage comes in. Plug the meter in series, and then you have to obviously move the probes around or whatever. Got it set out on a 10 amp scale. So if we kick it on now, so it's showing me close to an amp that it's pulling, just sitting idle, which is definitely no bueno, right? So you can imagine that would drain your battery in a hurry, and it does. It kills a almost fully charged Optima battery overnight. So anyway, so I know that this computer has got some problems. I would expect, even previously, I would expect that you wouldn't be able to even see any voltage coming out of the 5-volt and ground sites over here unless you hooked something up to the ignition wire, right? So unless you put power into the fused ignition to tell the computer, hey, I need you to power up and pay attention and do some stuff, it shouldn't really be powering maybe anything except for a clock or some, just some very minimal, systems on this board, if anything, to keep memory or, like I said, clock, like a clock state, something like that. So anyway, so this pretty much kind of guarantees, I think, to me at least, that we need to open this thing up and get a look at what's going on in here, figure out what's getting hot right behind this, and then, who knows, it may not be the thing actually just getting hot, because if it's still getting hot, we know that it's doing something. It could be something downstream of that's shorted out. It could be a short, potentially along the board, edges of the board, or near one of these fasteners or something, or behind the connector, something may have gotten joggled loose. So anyway, that's what we're going to do next is pull these fasteners out, and we'll see about starting to open this case up. Alright, so I got the 4 of these screws out, just these Torx, come out of either corner here. And then I just got 2 flat blade screwdrivers. I grabbed some junky ones. This one I had already had to fix a tip on it in a grinder. So it was a little sharper than it should have been, which actually worked out nice, because I was able to kind of go in down this lip and start in. I just kind of started in on this corner a little bit. I kind of burred up the metal a little bit and kind of tabbed it up a little bit, bent it, it's fine. I think I can straighten that out and get it fixed. But once I got that kind of corner worked up, I was able to get this other screwdriver in and kind of work my way, you know, out from that corner. Got it split all the way open. I was kind of looking inside as I was opening up that crack just to make sure that there weren't like some kind of components or something, I don't know, bridging to the other side, or who knows. Just wanted to make sure I wasn't getting ready to destroy the thing completely. And now again, I saw a little bit about this on another video series, and what he was saying is, you know, you only get a certain number of times of opening this thing up, because it's actually got a flexible circuit board, or maybe it looks like some ribbon cables that are attached to the end of the circuit board down on the bottom here, and flexing this thing open and shut too many times, and it's going to break, and it won't be able to go back together. I could see I was kind of pulling some of this sealant up off the board a little bit as I was doing it. Like little strings were attached down here and up here, and I don't know, I guess if you go to seal the thing back together, you would just want to run some fresh silicone down on it or something, and just run the fasteners back in. But I guess we'll deal with that when we get to it. So anyway, I got it opened up a little bit here, at least enough to where we can start poking at some of these bits in here and seeing what's actually heating it up. So if I went by what I was seeing here, somewhere under this sticker down and around this area here, looks like there's some electrolytic capacitors and some cages down here. There's a big integrated circuit chip down here on the bottom. As I'm feeling the board, it feels like there's some conformal coating on the top of this. So everything's coated. It's kind of got a gummy feel to it. So I guess as I'm going through here and testing, I'll have to get something to remove that conformal coating off of the pins on that chip, so I can get a probe on top of it and start testing it out and seeing what's going on. But anyway, I'm going to start poking into this. I'll probably go ahead and put power back to it and feel around in here and see if I can identify exactly what's heating up, you know, individual chips that heating up, and then I'm just going to start running test points around on the board and seeing where the problem might exist. I mean, upon first look or first inspection here, I don't see anything necessarily that leads me to point a finger at any part of the board in particular. I don't see anything burnt or any dark colored spots or anything popped off the board, so that's a little bit concerning, because I guess you know, if there was an obvious problem or something was burnt up off the board, that always gives you something to start fixing. But without having that, we're just going to have to kind of do some testing and do a little guessing, I think, on this thing. So it looks like the version of this, I see a Motorola symbol, and I see 1994. I got some other numbers on there, but I guess this is a Motorola brand computer. So anyway, yeah, I'm going to get it powered back up and see if I can't track into it, and I'll probably make some more updates along the way. So here it is after I've had my way with it. So just like a book, right? Plugs on one side, got her opened all the way up, and then the center section sitting back here right now, but that was just kind of keeping the two halves spaced apart. I guess probably some of these chips on the inside, when this thing folds shut, they probably heat sink against that aluminum plate. That's a pretty solid chunk there. So anyway, so this is the chip right there that from the outside was heating up. So I just kind of used a little chunk of wood here, cut off an end of a 2x4 with kind of rounded corners on there, and just kind of used it as like a scraper tool, a burnishing tool that wasn't going to damage anything. So I just kind of scratched around on that or whatever. But yeah, I'll pull the numbers off of that and find out what that chip is exactly, and figure out if that's something that I can get a hold of, and see about swapping that out just minimally. So that's the only thing I can see that's wrong with this for right now. But kind of a neat board, made by Motorola, and it's like this flexible dual-sided PCB, so I can see the traces on the back side and the front side. So that real thin, I don't know if it's like a acetate or what they call that exactly, but you see the traces jumping across the spine of the book, as it were, there. But pretty slick, not bad for 1997, so kind of a good looking deal. Anyway, I'll figure out what that chip is and see about getting another one.